Hi, in this presentation we will discuss about computer system organization. This presentation contains computer system organization, interrupts, storage structure and I/O structure. First, we're gonna see about computer system organization. A modern general-purpose computer system consists of one or more CPUs and a number of device controllers connected through a common bus that provides access between components and shared memory. Each device controller is in charge of a specific type of device. Depending on the controller, more than one device may be attached. For instance, one system USB port can connect to a USB hub, to which several devices can connect. A device controller maintains some local buffer storage and a set of special purpose registers. Operating systems have a device driver for each device controller. This device driver understands the device controller and provides the rest of the operating system with a uniform interface to the device.in. The below diagram memory contains CPU, disk controller, USB controller, graphics adapter. The disk controller handles disk, then the USB controller handles mouse, keyboard, printer. And monitor is said to be the graphics adapter. Next, we are going to discuss about the interrupts in computer system organization. To start an I/O operation, the device driver loads the appropriate registers in the device controller. The device controller examines the contents of these registers to determine what action to take. The controller starts the transfer of data from the device to its local buffer. Once the transfer of data is complete, the device controller informs the device driver that it has finished its operation. The device driver then gives control to other parts of the operating system. Hardware may trigger an interrupt at any time by sending a signal to the CPU, usually by way of the system bus. When the CPU is interrupted, it stops what it is doing and immediately transfers execution to a fixed location. The fixed location usually contains the starting address where the service routine for the interrupt is located. The interrupt service routine executes. On completion, the CPU resumes the interrupted computation. Interrupts are an important part of a computer architecture. Each computer design has its own interrupt mechanism, but several functions are common. The CPU hardware has a wire called the interrupt request line that the CPU senses after executing every instruction. In the above diagram, interrupt timeline for a single program is discussed. Device controller raises an interrupt by asserting a signal on the interrupt request line. The CPU catches the interrupt and dispatches it to the interrupt handler, and the handler clears the interrupt by servicing the device.in. The above diagram device driver initiates input-output device and transfer it to the input-output controller. Then the I/O controller generates interrupt and send it to the CPU. Then the CPU receives the interrupt and transfers it to the interrupt handler. The interrupt processes the data. And returns from the interrupt. Then at last CPU resumes processing of interrupted task. The upcoming slide is about storage structure. The CPU can load instructions only from memory, so any programs must first be loaded into memory to run. General-purpose computers run most of their programs from rewritable memory, called main memory. Main memory commonly is implemented in a semiconductor technology called dynamic random access memory, DRAM. Computers use other forms of memory as well. For example, the first program to run on computer power on is a bootstrap program, which then loads the operating system. Since RAM is volatile, loses its content when power is turned off or otherwise lost, we cannot trust it to hold the bootstrap program. Instead, for this and some other purposes, the computer uses Electri, not Kali erasable programmable read-only memory, EEPROM, and other forms of firmware, storage that is infrequently written to and is non-volatile. In the above diagram storage structure hierarchy based on the storage capacity and the storage structure is discussed. At last, we are going to discuss about I/O structure. Input-output devices are essential components of a computer system that allow users to interact with the machine. These devices include keyboards, mice, monitors, and printers, among others. Keyboards and mice are used for inputting data into the computer, while monitors and printers are used for outputting information from the computer. Each of these devices has its own unique characteristics and uses, making them integral parts of any computer system. A large portion of operating system code is dedicated to managing I/O, both because of its importance to the reliability and performance of a system and because of the varying nature of the devices.